everybody. Howdy, Annalisa. Check out these similar trapezoids. We'll do this little workout fun with similar trapezoids, and I'm telling you that these trapezoids are similar. Aren't all trapezoids similar? No, they aren't. Their sides have to be in proportion, and that's not always true. But it is true for these. We can know that these sides are in proportion. This tells me a similarity statement. Trapezoid ABCD is similar to trapezoid PQRS. So just as in the order that you would expect, I think we would know that angle P is congruent to angle A. But I'm not going to concern myself with angles right now. Write a proportion using the corresponding sides of the similar trapezoids and solve it. There's a bunch of different proportions that are available, but I'm going to do one that's kind of obvious to me. The top of this trapezoid, the top base, 2x plus 4, is to the top base of this trapezoid, 4x plus 1, as about the bottom base of this trapezoid is to the bottom base of that one. If the sides are in proportion, that would have to be true. So I'll continue with 2x plus 4 is to 4x plus 1. The top is to the top as the bottom, 4x plus 2, is to the bottom here, 6x plus 3. Now, this is going to be a little bit of an interesting proportion to solve. I'm going to go for the product of the means first, and try to be careful this time through, because it's a little bit complicated. I'll be multiplying 4x plus 1 times 4x plus 2. And you got to remember, we got to multiply first, outside, inside, last. First term times first term, 16x squared. Let me get back to this. Let me continue what I should be writing right here. Aren't I going to multiply those now? The product of the means is equal to the product of the extremes. And so over here I should have 2x plus 4 times 6x plus 3. Now I got to get back to business here. First term times first term gave me 16x squared. I'm going to do the outsides and the insides together. Outside terms give me 8x, and the inside terms give me 4x. 8x and 4x give me 12x. And the last term here times the last term there is a positive 2. Equals, now multiply these carefully. And you ought to multiply them before I do, but I'm going to charge right through there. But you could pause this video and multiply those now. First term times first term, yeah, that's going to be 12x squared, isn't it? Outside terms give me 6x, and the inside terms give me 24x. So 6x and 24x give me 30x. Plus, and the last term here times the last term there, there's 12. In this quadratic, like any other quadratic you ever work with, you're going to have to set it equal to 0 first. Should I put it all to the left or all to the right? Because I have a larger squared term, 16x squared on the left, I'd pull everything to the left-hand side. Let's subtract 12x squared from both sides, which would just leave 4x squared here. Subtract 30x from both sides, and 12 take away 30 be a negative 18x, I think. I got to bring this positive 12 to the other side, so I have a positive 2 minus 12 would give me a negative 10 equals to 0. Whenever we solve a quadratic, we'll always set it equal to 0 first. Is there anything we can do with this quadratic to make it easier to factor? I'm going to bring it up here, because I got some more things to do with this guy. And you say, well, there's a common 2 across here. There's a 4 here, but 4 won't go into those. But 2 goes into all of those 3 factors. Let's pull off that common 2. 2 times, and you're going to think, what goes in this pair of parentheses? So it would give you this back again. 2 times 2x squared minus, because of the minus sign here, and 2 times what gives me that 18x? Yeah, that's going to have to be 9x minus, and 2 times 5 would give me that negative 10. So I say that these two equations are the same equation essentially, but this will be easier to factor. Let's set out to factor it. I'll keep the 2, although it won't be a player, and see if we can't factor this cleanly. You'll shut down the video and factor it before I do, but I'm going to go ahead and factor it right now. I got to find the factors of 2x squared that fall here and here. That's got to be 2x and 1x. Nothing else could happen there. Then I got to find the factors of 5 and put them here and here. And we have to arrange them so I get this middle term to be 9, a negative 9 at that. Putting those terms, the factors of 5, I see that I'll have to put the 5 here and a 1 there. Yeah, 1 times 5 will give me that 5 that I wanted, but this has to be a negative 5, and that middle term is negative. So somebody's got to be negative here, and I hope you're thinking that this 2x times that 5 would give us 10x. Let's make that 10x be negative, and this 1x be positive, and then the outside terms, negative 10x, and the inside terms, positive 1x, would give us the middle term of negative 9x. So I say, hey, this is properly factored. This is the right way to go. And you recognize if the product of 3 factors is equal to 0, then one of those factors must be 0. I'll set them both equal to 0, see what happens. 2x plus 1 could equal to 0. And work on that for a second, and 2x would equal to negative 1. And then dividing both sides by 2, I think that x is equal to negative 1/2. I'm not worried about x being negative. I'm worried about lengths being negative, though. And this length would have to have been negative if x was a negative 1/2. 3 times a negative 1/2 would be negative 1.5. That's no good. That's an erroneous root. However, we got another place to look, don't we? X minus 5 could have been equal to 0, and if x minus 5 is equal to 0, then x is equal to 5. I think that might be the valid root. So I've written a proportion, and I've solved it. I think that x is going to equal to 5. In a minute, I'm going to probably have to go find the lengths on these 2 trapezoids. But here it says, write a different proportion in terms of x and solve it. And the truth is, we're going to get that same answer, but I just know it's really good practice to write different proportions. And there's a multitude of different things you could write. You could write this length, x plus 5, is to this length 3x. Is this base 4x plus 2 is to this base 6x plus 3. You could say, the top base is to the top base is this edge on the right. Edge on the right is to the other edge on the right. Lots of things are available. I'm just going to choose one and go. I'm going to say x plus 5 is to, and who corresponds with this x plus 5? It must be this 3x as, how about the bottom is to the bottom? 4x plus 2 is to 6x plus 3. I chose those kind of arbitrarily. I think it is a valid proportion. This edge is to that edge as this base is to that base. Makes sense to me. That should be truthful. So let's cross multiply and see what it comes. Let's go for the product of the means first. So multiply those, and what do you get? 12x squared plus 3x times 2 going to be 6x equals. Now let's find the product of the extremes in the first and fourth position. You got to be thinking first term times first term would give us 6x squared. Outside terms give me 3x, and the inside terms give me 30x. So I got 3x and 30x. That must be about 33x, huh? And last times last, 15. So, pretty good looking quadratic equation there. Let's set it equal to 0. Should I bring it all to the left or all to the right? Got stuff on both sides. Since I have a bigger squared term on the left-hand side, let's bring everything to the left. I don't only want to factor things when I have the leading coefficient is positive, when the squared term is positive. So we should subtract 6x squared from both sides, which would leave me with 6x squared here. 12x squared, take away 6x squared. And as I subtract 33x from both sides, 6x take away 33x ought to be a negative 27x. Bring that 15 to the other side. It's got nobody to combine with, but it'll leave me with a negative 15 is equal to 0. A good place would be to shut this video down and you solve that quadratic. But me, I think I'm going to continue in this fashion. I wonder, is there some number that I can clean this up and take out a common factor? Yeah. 3 goes into all of them, doesn't it? This is the same as 3 times a bunch of stuff to give me that back again. 3 times 2x squared minus, and 3 times 9x would give me that 27x. And because I got a minus sign, I got to go minus again, and 3 times 5 would give me that 15. So I'm thinking, hey, here's a beginning to factorization of this big quadratic. Let's pull it over here and work on it some more. 3 times, and I'm going to have to find a way to factor this fella. Looking for the factors of 2x squared. What else could they be besides 2x and 1x? Now I got to find the factors of 5. Oh look, this quadratic is just like the last one. That doesn't always happen that way. Sometimes you get a different quadratic, but with the same roots. But this one's going to be just as the last one was. I'm looking for the factors of 5, and I realized I could put a 5 here and a 1 there. And that 1 times 5 would give me that negative 5 that I wanted. Am I going to get that negative 9 in the middle? Yes, I would. I got to think when I multiply those, I want that to be a negative 10x. And I multiply these, that would be a positive 1x. And that would go together to give me this negative 9x in the middle. And when we set these factors equal to 0, 3 is never going to equal to 0. But 2x plus 1 could equal to 0, or x minus 5 could equal to 0. So x is equal here, again, negative 1/2, or x is equal here to a positive 5. Yep, so although we started with a very different proportion, we got the same roots, don't we? Had you done this side is to, that's you could have compared other sides, written other proportions, and come up with, you would have correctly come up with the same value for x. Now that we have the value of x, and we've confirmed it, done a couple of ways to show that it had to be true, find the scale factor between the two trapezoids. And what I'm going to do is just remember that x is 5 and figure out some lengths. That top length would have been 14. Bottom length would have been, let x be 5. 4 times 5, 20 plus 2 would be 22 there. I'm going to go figure them all out and see if I can't get all those sides to be in the same proportion. X is still equal to 5, so this length would have been 10. And this is 2 times 5, also 10. Hey, we got an isosceles trapezoid there, don't we? This one better be isosceles as well. Let x be 5, so this top base would have been 21. The bottom base ought to be, let x be 5. Oh, I'm sorry, let x be 5. 6 times 5 is 30, plus 3 be 33. What about these lengths? X being 5, this would have been 15. And this would have been 2 times 5 is 10 plus 5, we're going to be 15. Hey, it's also isosceles. That makes sense. If they're similar and one's isosceles, the other one would be as well. Now, let's get that scale factor. Lots of things you could do. You could compare the perimeters, or you could compare the upper base to the upper base. Would make sense too, wouldn't it? Upper base 14 is to the lower base, is to the upper base 21. Hey, that'd be a ratio of 2 to 3, wouldn't it? Yeah. But now compare other lengths as well. What about the lower base? The lower base on this small trapezoid was 22. The lower base on the bigger trapezoid was 33. That going to clean up? Yeah, it does. That's 11 goes into both of them. It's still a ratio of 2 to 3. Had I compared the other edges, the 10 to the 15, yeah, that's going to be the same idea, huh? 10 to 15, still in a ratio of 2 to 3. Had we found the perimeters, they would have been also in a ratio of 2 to 3, but I won't force you to do that right now. Show the process as you find the lengths of the medians in the two trapezoids and the scale factor between the two medians. I bet the scale factor between the medians will also be 2 to 3. So you got to figure out with me, what's the length of that median right there? And how do you get a median in a trapezoid anyway? Well, add the bases and divide by 2 to get the length of that median. So the first median ought to be 14 plus 22 divided by 2. I'm sorry, I hid that from you. 14 plus 22 divided by 2 looks like 36 divided by 2, and that would be 18. The length of the median in the smaller trapezoid is 18. How about the median in that bigger trapezoid anyway, huh? Well, let's add up the bases and divide by 2. Base 1, 21, plus base, plus base 2, 33. Add them up, divide by 2. That looks to me like 54. 54 divided by 2 gives me a length for 27. I am convinced that the median in this trapezoid would be of length 27. Now, let's compare the scale factor between the two medians. Well, one of them was 18, and one of them was 27. But we can reduce that ratio, can't we? Yeah, 9 goes into both of them, so this is a ratio of 2 to 3. So I'm happy about it. That worked out just like it should. The scale factor between the two trapezoids was 2 to 3. The ratio between the two medians is also 2 to 3. Everything on these trapezoids is in a ratio of 2 to 3. Now I've got a page kind of like this one, even more fun with similar trapezoids, and that's the one that you're going to want to turn in.